Welcome to the Institution of Engineers, Sri Lanka. This is probably the 7th public lecture for the session 2014-2015 from the Mechanical Engineering Sectional Committee. My name is Arjuna Manamperi. I'm the chairman of the current session. We have a very interesting topic, actually somewhat cutting edge, I would say. I'll keep things very simple and give most of the time available to our learned speaker, presenter, Dr. Athula Ginige. Dr. Athula Ginige, I'm not going into this long list of description about himself because it's all up on the internet. Everybody must have read it and you can Google him up, it's all over the place. So there's no need to give too much details about him. But the important thing is he's a product of Sri Lanka. He lives now in Australia and does most of his doctoral work there. He's a very seasoned veteran in the game. Today's topic, the way I would describe it is like this. I think we hear enough times now that Sri Lanka has more mobile phones than people who are living in the country, which is actually true. I bet some of you have more than one phone right now. Some of you have more than one phone. I of course carried a 1,500 rupee phone. The reason I'm pulling it out is very important. So this is my phone, right? I'm high tech, but my phone is not so high tech. Because today's lecture, I think, Athula, if I'm right, you're going to focus on some of the ways you got the information through SMSs. I think it's not just smartphones, but it is also SMSs. I personally believe it's one of the most powerful ways to communicate today, particularly in Sri Lanka and places like Asian countries. January 8th, there's a big election coming up. I'm sure your phones are flooded with SMSs right now from all kinds of people. So the people are using phones in a very big way in the mobile world. So without any further ado, I would like to invite Dr. Athula Ginige, who will talk about how he put this mobile technology, gathering information. I don't want to throw the word big data too much into this conversation, but somewhat akin to that, how he has been able to work with our own farmers and then the people from Australia to come up with a certain game plan to get information and connect with this farming community and get a lot of intelligence to them as well as from them. Athula, without further ado, please give a warm welcome.
Thank you, Arjuna, for the introduction, and good afternoon, ladies and gentlemen. I think it's a pleasure for me to share some of my work with you all today. Especially, it is a situation where we talk about technology being brought from developed world to developing world. And today I'm going to show you how the technologies we develop for Sri Lankan farmers are now getting used to organize the knowledge base of Sydney Rail, as well as there's many more things happening. On the way here, I was at National University of Singapore. I gave a talk about this, and immediately they said, let's do something, especially in the health space. And they also said, can it be done in Sri Lanka? I had some discussions, and I have a response saying, yes, because we can do something in the health space as well. So this technology we develop for farmers are not only limited to the farming domain, it's used in many other contexts in Australia now. I had people visiting me from Austria recently, and I was asked to go and give a talk in Sweden where they're trying to use this in medical health, manufacturing, knowledge and innovation ecosystems. So it's quite an interesting journey, and I'm going to share that with you today. Now we talk about computing, and the reality is there is a new era of computing which is dawned on us. As Arjuna said, yes, we are going to have a huge increase in mobile usage. Yes, it may be the SMS type phones at present, but soon, now at the moment, the rate of consumption of smartphones is more than the normal SMS phones. And give another year or two, we'll have more smartphones. If you even look at the price, even in Sri Lanka, it's about 10,000 to 15,000. You can get a good smartphones, and those are the phones we have been using with the farmers. The other important thing that's happening is a phone is now no longer just a phone, because it has a GPS, it has cameras, it can collect sound, users can input text. So we can see these phones as a sensor in the hands of humans. It can do lot more than a traditional phone. Then something interesting came up. Again, you will see I have been collaborating with a group of people, and one of them is Professor Ramesh Jain from University of California, Irvine. And he showed us some interesting statistics. If you look at the world population, 7 billion, almost 6 billion is now connected. It's huge. Nowhere in our human history we had a situation of that level of connectivity. But what is interesting is, of that, only 1.5 billion in the developed world, maybe Australia, USA, UK, but the rest 3.5 billion people are in the developing world. Maybe Sri Lanka, think of India, China, the two biggest population things, Indonesia. So you can see, and then the Latin America, Eastern Europe, take that is 3.5 billion compared to the top 1.5 billion, but we have about 5 billion people around this slide is a bit old now, is now reaching closer to 6 billion, connected to the internet. We have a connected society. And then there's this bottom 1.5 billion, which is actually diminishing now. They are the people in the sub-Saharan parts of Africa, etc., where there is no mobile signal, so they are not yet connected. So what does that mean? And if we really look at the applications we have, like Facebook, Twitter, if you are familiar with YouTube, they are mainly catering for the needs of this top 1.5 billion. Like our farmers or our, say, tuk-tuk drivers, they will not use the Facebook or the Twitter or the YouTube. They might still use the YouTube to get a video, listen to some music. And what emerged was, if you are familiar with this, what is known as Maslow's hierarchy of need, at the bottom level, we have the physiological needs, then we have the safety type needs, followed by the belongingness, esteem, and self-actualization. And people, when the needs of a lower level is satisfied, go only interested in the needs of the higher level. Like, if you don't have food, you will risk your life to get the food. But if you have food, you need to have a safety, that food security, you can have the food tomorrow, you have a job tomorrow. And if you are in that, you need to be in a society, and you feel that you have to be in a society. And in that society, you need to be acknowledged, and the esteem comes. And then if you are really well off, and once you achieve all this, like Bill Gates, they go to the self-actualization, where they start giving back. This system has been happening, and if you really look at all these applications, like if you take something like Facebook, which is now reaching 1 billion users, and if you really look at what does it provide in this spectrum, it is the belongingness. You feel you are connected, you share information. You expect when you put something for them to click on like. And what is it? It's an acknowledgement. I have heard that people are sort of competing, oh, I have this many likes. This is self-esteem. So if you look at most of those very popular applications, they are very much level 3, 4 applications. But these people, this nearly 4 billion, need applications here, which is in the safety, food security, job, support for livelihood activities. And till recently, no one has really thought about it in this way. And this has become now possible, and based on that, connecting this large mass, we have got a new era of computing emerging as social computing. So this is the backdrop to the work we have been doing. And having realized this, group of us said, look, what can we do to create applications that will help people in this developing world, that will livelihood activities. We actually did a bit of a global search because I have got quite a lot of links in Sri Lanka with the University of Colombo. We started looking at some possibilities here. My international collaborators also once came, that's in 2011 October. We went to various villages, etc. in Sri Lanka and found there's a very interesting problem. And I think all of you all should be familiar with this. Every 3 months, 4 months, these are very familiar newspaper articles. Everyone has produced carrots, everyone has produced leeks, everyone has produced tomatoes, they can't sell it. So we have this particular situation and we ask the question, can we use our mobile phones and this whole notion of sharing information to address this? Now to solve this problem, we were able to get together or assemble a very interesting research team. In Sri Lanka, it was based at University of Colombo and Ruhuna, and we have got researchers joining us to look at the Sri Lankan context. In Australia, 3 universities came together to solve this problem. My university, University of Western Sydney, Macquarie University and Australian Catholic University. Then a team from Italy came who was specializing in computer interface design, and they said they want to be a part of this experiment. And also the Professor Ramesh Jain and his team said, yes, we will also contribute some of the cutting edge technologies to solve this problem. So we started as an international collaborative team to look into this farmers problem in Sri Lanka, which was a very interesting journey. And in order to solve that, Professor Ramesh Jain and his team from University of California contributed some very interesting technology, because you all are familiar with social networks, and social networks like Facebook, they connect people to people. They showed that no, we can go beyond that and create what is known as social life networks. And I'll just take a little bit of time to explain that bit of technology. Connecting people and resources is the idea. Because if you take all these SMS or tweets or status updates, they are stored in various data centers as microblogs or small snippets. So someone say, look, I'm having a stomachache. Who cares? So what? But somebody said, I am having a stomachache in the morning, but in the timeline, last night, that person was at a restaurant. And then there's the picture of the friends, because people can be tagged. And those people, when they are looking at their timeline of the 10, 7 are having stomach aches. And then the restaurant name is there. You look at who else was there on the restaurant. And then another group of people are reporting about stomach ache. Suddenly something new is emerging. There has been some food poisoning. See, those microblogs in isolation, but once you start connecting them, some very valuable information can emerge. I'll give you so basically to do that, they have developed technologies like aggregation and composition. Then from that, detecting the situations. And from that, new information, alert queries can be generated. And that can be then can be used in health, education, agriculture, transport, social. So new possibilities have opened up from some of the interesting work the University of California work have done. Now here's another interesting example just to explain that particular phenomenon a bit more. They did an experiment, I think this is a couple of years ago, where they looked at the tweets, you know the Twitter. People are just messaging, I want this, I like this is my mood, etc. They looked at the messages people were sending, saying that I want an iPhone. Because this was just before release of a new iPhone. So, and what they did was, because the other thing is with mobile is when you send a message, you get the geo coordinates. So if people are, if the text is something to say like I want iPhone or something similar, what they did was they took a map of US and put one, if there's a first message. And at that location, in that small square area, there was a second message, they put a 2, 3, 4. So if you look at a matrix, you have these squares and the numbers are increasing. They collected that over a period of time and added them all together. So in that time window, this was the aggregated interest for people expressing they want iPhone. Then they took, this diagram is not very clear here, these were the locations of iPhone retailers, again the coordinates. And then they looked at, normally if a shop is here, what is the radius that can be covered? The operator called convolution and created the area covered. So on one side we have the demand, on one side we have the supply. When you subtract, you get the area where there is a demand and no supply. And then you do the reverse convolution to find the centroid of those areas. And then they said, look, if you start an iPhone store in this geo coordinate, which happens to be somewhere in California Bay Area, that you will have the maximum possibility of succeeding. So we don't think of these tweets and whatever, but the idea was to see by we can derive new information, and they have done it for asthma, the pollution, pollen counts now, and spread of fever, lots of things. They have done these algorithms, which is opening up this, using these small messages, lot of new possibilities. So based on that, we looked at how can we solve the problem of our farmers. So the conceptually, if they start sharing what they are growing, and if we can aggregate that and make that totals available to them somehow, saying that the current production of tomatoes, this is the current production of leeks, this is the current production of carrot, we were expecting they will change their behavior. If they ask what crop to grow, and if they says, look, these are the current production levels, obviously now they are going to make a decision based on this new information. So this was our conceptual solution, but the reality is it's not that easy to implement. So we went through a very interesting journey using an approach called design science research. I will not go into the details, but basically it consists of set of iterative cycles. You start with a cycle called relevance, where you analyze what the problem is. Then you look at a rigor cycle, what is the known knowledge about it. Then you go into a design cycle and do some design. Then you validate your design as a functional test or just standalone. Then you actually go take it to the field and validate it. And then the learnings are put back into the knowledge base. But you can move in any order, starting with relevance, and keep running through this until you find a solution. So this is a fairly established research method. We used that and went through a very interesting journey of multiple iterations. So this is a relevance cycle 1, application domain. We had studied the farmers, the farming decision making patterns. Then we visualized how this information can be presented. Then we developed an ontological knowledge development base, which I'll talk to a bit more. Then we had another question, user empowerment, and all this I'm going to explain in detail. But instead of doing that, after going through this journey, we ended up with what is now we call a digital knowledge ecosystem. So instead of trying to explain all that, if we have this knowledge, I will show you, if we are going to do that project again, how we will do this, because that's the new knowledge. And then I will show you how the same approach can be used for the railways and many other situations. So this is the architecture of the farming application that evolved after this iteration. I will briefly explain, but I'm going to expand all this in more detail. This is the overview. The important point is you can see there's 4 labels here, or this architecture consists of 4 layers. And here there is a aggregation and disaggregation layer. There is a information flow model, user empowerment process, and user experience layer. And in fact, these are actual screenshots of this application, which will become available hopefully by end January for people here to use on a constant basis. We have done 2 major field trials in 2012 and 13, and then now we are just finalizing some of the IT issues, and it will become available hopefully by January. And if you look at it, it will have all 3 languages. So the important point that evolved with this work was that this type of a problem, we need to work at 3 different levels, which, as I mentioned, information flow and storage layer, aggregation and disaggregation layer, user empowerment process layer, and user experience layer. So let's look at these 4 layers in somewhat detail now. And the starting point of, if you are going to redo this, so the way we are doing railways and now the health and everything, because of the insights we gain, is information flow and storage layer. That's the starting point. Now when we look back and look at how the information flow in our farming domain, we can show it in a situation like this. We have got the farmers, agriculture extension officers, and from the agriculture extension officers, farmers get information about the various varieties, about pests, diseases. But in return, agriculture extension officers needs to collect from farmers what the farmers are cultivating. And that information gets aggregated district by district and comes to the agriculture department, and they need to report that to a cabinet subcommittee which is looking at food security. They need to know, say in February, how much tomatoes or rice or coconut will be available to the market, what is the demand. If there's a shortage, they need to start giving export permits, import permits now, because there's that lead time. And if there's a shortage or if there's excess, they should not give or think of even exporting. They cannot do it 2 months later. If they get it wrong, there will be oversupply as well as you are importing. You can see the balancing act. So this information is quite critical, but at the moment it's manually collected, put it into spreadsheets at different levels. By the time this gets produced and reported, it's about 3 months or more. And that's why one of the reasons we are having this somewhat unstable supply-demand situations. But this is the flow model at the moment. PhD students from University of Colombo, she did quite a bit of analysis, spent time with farmers to understand how farmers decide what crop to grow, how they select whether it's to grow carrot, leeks, etc. Basically, it emerged, it's revenue driven, and one of the deciding factors was the price of the previous season. But then we found it's not only that, there was a lot more. The selling price is determined by the yield quality, because there were situations of people producing but new hybrid, different size couldn't sell, the supply and the demand. But then all this depends on another set of factors: the weather, pest and diseases, fertilizer, the new methods of harvesting or techniques that's been developed, seed quality, previous year price, number of suppliers, government policies, there are subsidies being offered, and number of buyers in the market. And if you look at the life cycle pattern, there's the crop choosing phase, the crop growing patterns, and the crop selling patterns at different times. To make an optimal decision, you need to have a view of all this. So you can see what they get, how they make decisions, and what should be sort of a more optimal situation. So this is the same diagram, the farmer as the center, and this is the information they want on crop choosing phase, crop growing phase, crop selling phase. But we went a step ahead further and looked at who can provide this information. For here, this was the Department of Meteorology for the weather, Department of the Ministry of Agriculture for some, the various research institutions. So we expanded from farmers to the whole domain and looked at who can provide the information farmers want. So the expectation was, yes, they will provide information, and if we can get it to the farmers, then farmers will be able to make a better decision. But the question is, again, those who have tried to create knowledge systems or all those data collection things will know what is the incentive for them to provide this information. Why should they provide this information? Maybe partly because it's their job, they are paid for it. But then, can we have something more? If you look at something like the Facebook, see, the people participate with some sort of enthusiasm, and there has to be a reward back to them. So we went further, and this is one of the very interesting discoveries we did in this project, that if you look at all the stakeholders, farmers are marked as F in the next slide, production assistants, so the APAs in Sri Lanka, agriculture instructors, AIs, Department of Agriculture, DOA, the ministry, the agrochemical companies, the buyers, the financial institutions, banks, the middlemen who will provide money, and the metrology department. What we found was that all these groups need information. Suitable crops and varieties, farmers want it, APAs needs to know it, agriculture extension officers needs to know it. Then if you look at something here, the market prices, all these people want to know it, including Department of Agriculture. You have the Hector Backadua Research Institute collecting that. They are all different entities not working together. Then something like this, aggregated plant crop extent. That is being required. Not farmers need to know how much being produced in order to decide whether to grow this or that. But similarly, as I mentioned earlier, agrochemical companies would like to know what is being produced in order to plan their supply chains for importing chemicals and fertilizer. So we found a very interesting dependency of information among all these players. Some of that we identified as static, that is prior knowledge, it is in books, it is in leaflets, which they would like to have. But some of that is actually dynamic, produced by when they grow, an aggregation produce the information. Now you can relate back to what I showed, the technologies from the University of California of aggregating and getting that information. We saw this pattern. And if we did little bit more and look at the information mapping, the expected crop to grow, we can even go to a detail of the crop, the variety, number of acres, planned months, cultivated crops again, the plant date, harvest date. So we can go even to another level and say, look, for each of these bits of information, this is the type of parameters we like to have. Once you have it, we found we can create a mapping. Aggregated plant crop extent is by aggregating set of information that they are producing. Aggregated cultivated crop extent, again through an aggregation operation we can calculate that. If you look at this agriculture knowledge on crops and varieties, now you see the aggregate here, it is disaggregation, and I'll talk about it little bit later what this disaggregation means. So some of the information people want, stakeholders, can be generated through an operator called aggregation, and some of the information people want is not only farmers, now all the stakeholders through operation called disaggregation. And we then realize we can have actually a stakeholder information model, because these are all the stakeholders. If they provide their input through these two operators, aggregation and disaggregation, we can actually create the information that they want. Only exception to that was the meteorology department. We need their input, but they don't need any information back from them for their operations. But all the others were depending on the same information. Here it is just saying, look, you are giving us the weather information, it is the goodwill, or they benefit indirectly by having more stable prices, but there was no direct input for this. But all this information, by aggregating, we were able to fulfill the information needs in the domain. Now if I move on to disaggregation, now if you look at Sri Lankan situation, we have a fairly good website by the agriculture department, there are leaflets, there's newspaper articles, there's TV programs, radio programs, and farmers want information, but they have these big chunks of information. But what they want is not all this. They don't have time to read. When you want information and search Google, you get all these things which you need to filter. But you want the answer to your question. So they want the information in the specific context, which is maybe to do with some fertilizer, how to store the harvest or particular disease. This is what they want. And this information cannot be provided through normal database technologies. That's what we found. We have to go and develop an ontology. And we had a lecturer from Roon, actually she has just joined us, she's here in the audience, came to Sydney, spent 2 years with us and developed this technology called ontology. And through that, we can now provide this information in context through the mobile, plus we are also developing a standalone website for anyone to go and search, because various research institutions, government organizations can benefit from this. It can give very specific answers to your questions based on already published information. We are just reorganizing and presenting it. For example, a farmers want to know what crops will grow in my farm. So what is my farm? So what we did was, my farm is a location. Mobile sensors, geo-coordinates, so we know the location. Sri Lanka has agroecological maps, agroecological zones. So from these location coordinates, we can see whether it is wet country, low elevation, high elevation, or dry country. We can get the agroecological zone. And then after reorganizing the existing information in various leaflets into this ontology, we can query, look, under these conditions, which is the representation of my farm, which is the soil, the climatic condition, elevation, what crops will grow? We get a list of crops that will grow. And we went further and like what fertilizer to use, how to manage the diseases, and even the way you apply fertilizer depends on the type of irrigation, whether it is rain-fed, tank-fed, the soil types, and multiple parameters. And she developed some complex mappings. I'll just show you the mappings. I'm not going to explain, just to show you all that yes, it's not straightforward, but that particular know-how is now available to you all in Sri Lanka because she has come back. If you all are going to do something like that, that knowledge is now available, and this is what the mapping for fertilizer depends, which is the crop uses fertilizer to be considered. And it was even more challenging when we were trying to see how a particular disease can be managed. And you can see the complexity again. Crop, there's a growing problem, and a growing problem has a control method, because these control methods may be putting chemicals, maybe putting some organic methods, or maybe traditional. Sometimes people plant other trees in order to keep a particular pest away. So we were accounting for all that. That's where this whole complexity comes. It's not a very superficial thing. It's a very deep knowledge base that we have developed for the Sri Lankan farming industry. So at the moment, that ontology has about 75 data properties, 195 relations. And the thing is, in this, you can actually do some logical processing or inferencing. If we say, if we have a data point saying the leeks grow in Nuwara, and there's another data point to say the Nuwara is part of the upcountry wet zone or medium dry zone, whatever, then if you ask what crops will grow in this condition, the leeks will get picked up because it infer Nuwara is here, therefore leeks grows in this part. So that type of capabilities are there in an ontology, which is not there in a database. Then if you look at the aggregation, as I mentioned, aggregate these points what farmers produce, whether it's carrot, etc., onto a map of Sri Lanka on a grid. And then using predictive modeling, you can start saying, look, in this area from the government statistics, we know there is 1,000 farmers. We have a sample of 100 or 20 farmers, and this is their production. Therefore, this is the prediction with this level of confidence for the population. So we can start predicting what farmers will grow once we know what they are doing for a sample. Now, this is all fine. We have a flow, share information. We have aggregation, disaggregation. Here is the $1 million question. We can do all this. Will people use it? Would users use information just because it is available? Because all the leaflets are there. When we go to the farmers, they say, yes, it's there, but we have not used it. And also, will they be happy to just share information? How do we make this happen? We look back, spent quite a bit of time, and again, that was research done by Tamara there, because in this project there are 1, 2, 3, 4, 5 PhDs. I'm compressing all that into the short. It's a huge project. The question is, what will empower people to share information? So we looked at Facebook. Why people are using Facebook? Why some of the social media becoming so, why people are sort of embracing social media in a fairly big way, very significant way. What are the properties? And what we found was they empower people. Because one of the attempts was sometimes to give financial incentives for them to provide data. Maybe you can get a grant or you can get a subsidy, but it is not sustainable. It will work for a while. It's not there, that will not work. But where Facebook and things, they are just growing. So if you look at what is empowerment, first it is the belief that goals can be achieved. They have some goals, it can be achieved through the system. That belief has to be there. It is an awareness of the resources that are available to achieve the goals. So then they will be looking at, okay, how can I achieve the goals? And it is about freedom to make choices and take actions to achieve a goal. You are not restricted, yes, I can do this, so that I am getting the information, I am free to make those choices. And from that, what we derived was, by providing timely information can greatly increase the people to take actions to gain better control over their livelihood activities. So if we can provide timely information to support their livelihood activities, that will empower them. So we wanted to test something, what their goals, whether they believe they can have choices. We went to the various places around Dambulla, Polonnaruwa and of Anuradhapura, a very remote area with lots of Galgamur, which is where they have got wild elephant problems, all that. We took quite a diverse sample of farmers, went and problems, all that. That was analyzed to see whatever happened, our farmers, yes, okay, it happened, now I'm getting on with it. They don't, keep crying, they'll go and again plant, again the elephant will come, and that cycle continues. They had a very positive attitude and a belief, and we felt by giving a bit of this help, they can greatly benefit, and they also felt the same. So after doing that analysis, we came to the conclusion that what it really means is we can embed the factual knowledge, what to grow, what pesticides to use, etc., within the procedural knowledge, because they were saying we don't have competence. So if we can guide them and at the right point inject the right information, that will be very helpful. As a result, today our application has got a module for crop selection, cultivation planning, and my offerings is a very interesting thing that emerged in these interviews, because a group of farmers in Polonnaruwa said, look, we have this particular problem with kidneys, there is overuse of pesticides, and they have started a grassroots movement to create organic fertilizer. And they said, look, we are now having enough for our communities, we like to make it available to the others. Therefore, we have actually taken that on board in our application. Now, they can say we have this much of compost to be made available to the others, and when the others are looking for fertilizer based on the distance, on the proximity, we can make that information available to them with a phone number where they can start buying and selling. So all that came through these interviews. And the fourth layer is the user experience. We can know all this, but if it is hard for users to use it, nothing will happen again. So we looked at the user experience layer, and this is one of the classic pictures which actually got our Italian group to redesign the whole interfaces. One of our farmers, this is one of our researchers, applications, you know, this swipe, we do this type of operations, but look at the finger. This is push button, basic, they wanted the push button interfaces. So if we didn't cater for this, they will not do the other things. Yes, we can have the other things, but we went and redesigned our interfaces to work with that single push button, and that's why I really like this. It tells a very interesting story, this single picture. So with all that, this is the application as now it looks when we launch it. 3 languages. We have got the basic someone can register, they'll get SMS registration system, and then there's the farmer login. Also you can just come as a guest just to explore if you want to get familiar with it rather than using it on a frequent basis. Then there's a password recovery, the usual things. But when you go to the main menu, you can modify my information. We have about them, the crop selection, an expense calculator, the expense history, because they can, over a period of time, they can see what they grew last season, what happened the year before, all that is now on record, and my offerings. And there's few more coming, which I. But when you go to crop selection, they can add a farm or select a farm which is already in the system. So to add a farm, either they can put a name of the farm, this Kumbura or this Yaya, and then you can say the land area, and either select it by the province, district, DES, and if you go down, we actually manage it down to the Grama Sevaka Nildari, GN divisions, all that there. Or instead of that, they can go to the map, and in the map they can select it, and then we again record the geo coordinates for the farm. Then when they select a farm, we can find out what will grow in that farm. They get the list. Now these were collected when we don't have much of a history, but with time what will happen is this list will come color coded. The ones that are in low production will appear in green, the ones are in mid production will appear in yellow, and the ones that are in high production will appear in red through the aggregation mechanism I mentioned. And we expect then for them to change their behavior pattern, what they will grow, because they can explore many more, not only what the things. When they select, say, tomatoes, it gives the tomato varieties. So we go down to that level of detail. It has to be realistic, otherwise it just tomato won't do. And then when they click on it, they can get more information about that and how to grow it. It's very customized to their farm. And then when they select a short list, they add to a short list, and then they can select each of those things in the short list and go to an expense calculator and work out how much it will cost for the pre-sowing stage, growing stage, harvesting, post-harvesting. They can get an idea of the cost. Now to do that, when they go to pre-sowing, they get the types and also who are the suppliers with this, how much they get, and they can calculate the cost. One thing in this is, in order to get to this fertilizer information, they need to provide how much they are growing. And once they say how much once they provide share the extent they are growing, then you get this additional information. And once they decide what to grow and make a short list, they can get more detailed information of how to grow it, when to apply, fertilize, everything. So in other words, they give some information, they get something back. There is an incentive now in terms of information to go from stage to stage, rather question. There is a motivation for them to do this, and then in the background this information get aggregated and that gets provided to others. For example, here we can now say in February in Matara the demand for urea will be this much, and the CIC when they heard this said, look, yes, we like to be part of it because we can use that to plan our supply chain. They know the demands. And then in one of the presentations, some people from the bank, National Bank, came and said, yes, join us, we will give them microfinance. Can you see how the stakeholders are coming on board? This is the details, but at a higher level, if you look at biological ecosystem, because my topic was knowledge ecosystem, we are living in an ecosystem because there are plants being eaten by some animals, that animals are being eaten by others, and people eat those animals. So we are building that energy flow, and then when plants or the animals die, we have another type of animals that come and the decay happen, the worms and all that, it get disintegrated to be consumed by, again, the ecosystem. So you will see in a nature, we have both the aggregation and disaggregation happening. And those are a lot more stable. They have stayed for years and years, whereas many other systems have stayed for 10 years, 5 years, or much shorter period. Where there is this ecosystem model, they have evolved for thousands of years. They are much stable system patterns. And if you really look at it, ecosystem, in biological ecosystems, we have got, it's a network or energy centric. And now we can start talking about digital ecosystems where the energy flow is being now replaced by information flow. I showed you the information flow models which we discovered is there in a domain. And then we are also now beginning to see this, like in a biological ecosystem, there's the dynamics of it. We are seeing the same patterns in the digital ecosystems as well. If you look at this farmer project, there was the farmers had the information need. They wanted the information in context. And then what we did was we brought in the prior knowledge, published knowledge, went through the disaggregation process I explained, and we were able to provide information in context, what will grow in my farm. Information was there in leaflets. By doing this, we can now answer what will grow in my farm, what fertilizer should I use. So the very specific information in context. Then what happens? They have choices, they are getting empowered, and in the process, they are also providing information back. How much they grow, how much fertilizer they use. It is not forced on them, it is part of the natural process. That's the important point. And then we can aggregate that, and through the aggregation, we can create new information. If you look at the flow model, the planned extent and all that, we can create. And then, and it is again been filtered based on the user context. And then that aggregation information is required by agriculture department or the CICs or the agrochemical companies, the banks. More stakeholders come, and the system is a gradual evolution of the system. Now, what does this got to do with Sydney Rails? Any thoughts? Can you think of a connection? Yeah, it's a lot more than that. Let me show you, because I'm a bit over time now. The Sydney Rail, after we were into about 1.5 years into the project, came and said, look, we have our engineering knowledge base. They have 965 You can't read it, sorry about this small type, but this is all disciplines, civil, electrical, rolling stock, signals, stations and buildings, telecommunication and track. And in that there are subdivisions. So the whole knowledge base of Sydney Rail had these standards which they had to adhere to when they are developing, tendering, designing, commissioning, all that. And the challenge was, this was evolved over 50 years in different silos, and there was no consistency, where it is very hard to maintain. And I'll show you about a trench, about a cable, about earthing and bonding is in many of these documents. If a new technology comes, if they change, they don't know where to change. And also, this is in electrical, civil. Now, if they want to create a new, design a new railway track from, say, to the new airport, Badgerys Creek, from a place called Penrith, they need little bit of civil, they need little bit of electrical, they need little bit of something else. Now, to get that, you have to go through this massive database. You cannot access that information in context. Can you see? One thing is maintenance, one is accessing it at the right time with the right information. So when this problem came, yes, they had the traceability issues, terminology changes, broken links, all that those problems were there. So I will not go through this, but this is basically to reflect the insights we got was, we can have a flow model, we have to provide information in context, and we can have this dynamic environment. And what I showed you in the ecology slide is the starting point is to provide the current static information in context, and that's where the ecology. And if you look at the standards, it is this point. They have the existing information which they had to access. So straight away I saw the pattern that emerged from the Sri Lankan farmers into this problem. And I told them, look, yes, don't think this is your problem. You can get something much bigger. But this is the starting point. So based on that, we looked at their standard evaluation process. Again, I am sure if you are working on standards, etc., this is a very common, where you need to get government stakeholders, external stakeholder interest, standard evaluation, the forums, the discussion forums, all that has to happen for the standards to evolve. And then once the information is there, as I mentioned, you need to be able to access them in context. And the context was the enterprise life cycle stages, system life cycle stages, and system life cycle phases. Again, as engineers, you will be quite familiar with these things. So they want to know the information in these contexts. So there is a user context, because a user can be a designer, a technician, or a high-level engineer or manager. They need different views of the information, not the same. Then there's a task context, what they are trying to do. Then there's a spatial context, the temporal context, and the environmental context. And then there's the topic context, where the civil, electrical, all that became very common. So our solution was, again, there was an information maintenance challenge and a specific information access challenge. And the solution was, we had to have an information architecture which should have certain properties. And those properties were, if you look at standard 1, 2, 3, in each standard there is a segment called cables. If you are taking this much of voltage, this should be the separation. Or if you have a trench, this should be the amount of insulation. So there are very specific statements. So we had to break this information source of truth 1, 2, 3, and the same thing was repeating in many standards, and we had to work out the one-to-one mapping, one-to-many mappings to reorganize this. And the question was, with these standards we cannot lose information because they have gone through a very rigorous process. We have to make sure we have captured everything, and it was too much. With agriculture we were looking around what 7 people looked at it and created it, but with these standards we couldn't do it. So the research challenges were to reorganize and use techniques like natural language processing to do it. For example, these are some of the engineering standards, and one of the very interesting areas is what is known as the combined service route, where it is the ducting going along a railway channel, where there is electrical power cables going, the signal cables going, and there is some mechanical civil constraints, everything. And if you look at some of things like a trench, about a trench, there were in 3 different standards in this small subset. So if you look at that, trench, and if you look at avoid filling material, because when you do a trench you have to sort of backfill it, the material properties were in 3 standards, and that is exactly what was in the 3 standards about the same concept. 2 were identical, this had something more. Because it's evolved, there was no single source of truth, they couldn't manage it. So we were able to extract this and say, look, here is a common representation of all 3, replace all 3 with this text and recombine the information to have a uniform architecture. That is for the individual things. Then also from different standards we were able to create a topic hierarchy. If you take cables, cable types, cable routes, cable laying, cable installation, information were spread, and we were able to, through our techniques of information extraction, create this and show that yes, there is this similarity, there is overlapping, and we were hoping to see any contradictions, which we didn't. 2 standards saying very contradictory things. So you can see that there is a major challenge of organizing information, even in the railway or any engineering domain or any health domain, this in many domains. So we did quite a bit of research to identify the automatic topic extraction, the relationship in extraction and context extraction, and came up with an initial system. Remember, the word initial is important. Now instead of those standards we have set of topics, and then we link those topics into topic maps, and from the topic maps we can get the original standard view. So if a user wants to look at any existing standard, they can do it, but now they are constructed using these extracted topics and linked through a topic map. But it also allows you to look at a asset is say a station is an asset, the rolling stock is an asset. So you can look at a rolling stock and look at what is relevant to that, or it could be a particular concept about the cables which I showed you, or it could be just a topic which writers will like to see what is there and modify it, and when you modify it, it appears in all that. So coming to the end, if you look at this problem, what the railway problem, there was the information need and there is a user context. And what we have done it is, we took the prior knowledge and we are providing the information in context now. So you can see this is the starting point, and normally people will think this is the project, but really what we saw after the farmer project is this is a starting point of a very big knowledge ecosystem, which they agreed, and that's why they started working with us. So once we finish this, that's the initial system, all the other things will start to happen around it, creating a much better and bigger knowledge base. So I have given a very quick overview of a very large area. So with that, I will sort of finish my presentation and leave it for any questions and feedback.
We begin the second half of the session. We have a discussion now with our presenter, Professor Athula Ginige, as well as some of the audience who are here. So I'll take my seat over there, and please turn this. So unfortunately today we are not live streaming the discussion. Normally we do that. Today, because of our technology that is available to us, only the lecture was live streamed. So the discussion will not be live streamed. So those of you who are watching this particular presentation, I'm sorry for today's situation, but maybe the next time. Thank you. Just on the